Morning, guys. How are you?
Good.
Woo! We hope you're doing great. Today we're doing area of irregular shapes, 3.6D. Here is our objective. I can decompose composite figures formed by rectangles into non-overlapping rectangles to determine the area of the original figure using the additive property of area. Here is area. Area is the measurement attribute that describes the number of unit squares or square units in a figure or regional covers, the region that it covers. Here is your thought question. Think about this while we're going through the slides. What strategies can be used to determine the area of an irregular shape?
Okay, so we're gonna do the area of irregular shapes. So that means this shape right here is not a shape that you see every day, okay? It's actually a rectangle and a square put together, it looks like, okay? So let's see what our question looks like. It says, Mr. Owen's porch has a square section and a rectangular section. So here's my square section and here's my rectangular section, as modeled by the shaded figure. Okay, so there is my rectangle and my square. It says, what is the area of the porch in square meters? Now we know area means to multiply, but there is going to be a whole different formula that we use because it's an irregular shape. Okay, so we're going to use the area of A plus the area of B to figure out the total area. Okay, so just like Mrs. Fiedel said, we're going to use the additive property. Okay, now the first thing I need to do is cut my figure. Okay, I don't want to look at it as one shape. You're not going to do the length times the width. Okay, remember we have, it looks like 3 steps now. So you're figuring out, you're multiplying one, then you're going to multiply the other, and then you're going to add the 2. Okay, so the first thing I need to do is cut my shape. So I've cut my shape this way. You could cut it this way if you want to, but I'm going to cut it up and down just because that's how I feel like doing it. Okay. After that, I need to figure out what my length is. Now, if I want the length over here, I can count and say 1, 2, 3, and know that my length is 3. And then my length up here is also 3 because whatever you do to the bottom, you do to the top, right? So here is my length now, and there's my length over there as well. All right, now I know my length is 3 and my width is 3 for my square section, and I know my length is 3 and my width is 6 for my rectangular section. Now I can multiply, okay? So 3 times 3, these two right here, 3 times 3 is 3, 6, 9, right there, it's 9. And then my area of my rectangular shape is 3 times 6, so 6, 12, 18, right? So now we're going to add 9 plus 18, okay? So I'm going to come over here and I'm going to add 18 plus 9. I put 18 on top because it is the biggest number. 8 plus 9 is 17. So I put my 7 in the ones place, and then I put my 1 in the tens place, and now I can add my tens place. So 1 plus 1 is 2, which means my area is 27 square meters, or 27 meters squared, however you want to say it. Okay, so this 2 right here just means squared. It's a fancy way of saying squared, so that I don't have to write it all out. Okay, so the answer is 27 meters squared.
Okay, guys. Our next question is, Denise planted a garden with a rectangular section and a square section as shown below. What is the area of the garden in square feet? So we're basically going to do the same thing, and we're going to use the same property, which is the additive property. Okay, so all we're going to do is we're going to split our rectangle and our square. Okay, and then you'll see that the area of A plus the area of B equals the total area. Again, that's our additive property. So splitting those apart, Then we're going to fill in our numbers. Now, off to the left, you see a 10. Okay, if I count those, there's 10 of those going up and down. Okay. Now, because we split our rectangle and our square, we don't have 8 across the bottom. We've only got 4 going across our rectangle. Okay. The other 4 come in our square. If you notice, we got 4 going across the bottom still, and you've got 4 going up the right side. Okay. So we're going to multiply those. Okay. Our 10 times 4, okay, 10, 20, 30, 40 will give us 40. And then our 4 times 4, 4, 8, 12, 16. So 4 times 4 is 16. Okay, so we go 10 times 4 plus 4 times 4. So 40 plus 16. Okay, so we add those together. Got 40 plus 16, 0 plus 6 is 6. Now I know some of you out there, especially some of my students, said 0 plus 6 is 0 because you're multiplying. Okay, but we're adding here. Okay, 0 plus 6 is 6. 4 plus 1 is 5. Okay, so our total area is 56 feet squared, or square feet. Okay, again, like Miss Garza said, the 2 there is just a square. Just keeps it shorter and simpler to write it out.
And here's your thought question. What strategies can be used to determine the area of an irregular shape?
Okay, so when we go back to this right here, we use the additive property. Okay, so we figured out the area of the rectangle, figured out the area of the square, and then we added both of our areas. So what we did was we came up with a 3-step solution to figure this out. Okay, if this is confusing to you, you can still make all of those extra little boxes and add all of those boxes. I do not recommend that though, because that's a lot of boxes. It's 56 squares to count. And so we're giving you an easier solution to do that. Now, if this is confusing, that would be a second step, but I still would like it if you would use the additive property to second double check your answer, is what I'm gonna say. All right, I hope you guys ate a whole bunch of candy, got a whole bunch of money from the Easter Bunny, got to see a whole bunch of your family. We love you guys, and we'll see you on Thursday.
See you guys.
Bye-bye.
Bye.